for this last video, I'll talk a little bit about the relays, and I'll show you guys just one last thing. Now this relay here is just a it's just a generic relay, 3 points, 3 terminals. It's actually 4 terminals because it gets the other terminal from the case. Okay, and solenoids, you know, they're all the basic ones are all 3 or 4 terminals, and the 3 terminals ones are really 4 terminals, but the case being the other terminal. Okay, not going to discuss exactly which terminal go to where, but the solenoid is really simple. Just an electromagnet with a set of contact points on top. Okay, closing the electromagnet, you put electricity through the electromagnet, magnetizes, and becomes a magnet, which that's what an electromagnet is. It's just a magnet that's turned on and off through electricity. Okay, so 2 of the terminals are the positive, basically the positive and the negative wires going to the magnet. Okay, which is just a roll of wire. So let's see. Yeah. So yeah, 2 of the wires, go to the magnet. One of them is positive, the other one is the negative. All right. Out of these 2 wires, one of them obviously has to go to the ignition switch, because electromagnets, they use up electricity, so you don't want it to be on all the time. All right. So you want it to switch the car off, turn the magnet off as well. Okay. So those 2 terminals, 2 of the terminals are the magnet. The other 2 terminals are just the other 2 contact points. Okay, that go, and they shouldn't matter which terminals you put where. Right? This may or may not be true for depending on the relay that you have. Because sometimes they turn on and off different ways. Some terminals need to be on, whereas the other one is just like off or connected to something else. So, but 4 terminals, 2 of them are for the magnet. The other 2 are the contact points that you want to connect, just like a switch. Okay, so 2 terminals basically are power of the switch, and the other 2 terminals are pretty much the switch itself. Right? Contact points are open like that. Magnet attracts it, closes. Turn the electricity off, magnet releases, spring pushes or pulls, depends on the relay that you have. Pulls or pushes the contact points open again. Okay, so there you have it. Yeah, this one's pretty well built. I believe it's from India. I know there's a bit of plastic there. I fucking hate plastic. But it's got, nice, pretty durable materials here. It's not brass, it's just sort of plated thing. But it's got screws. I don't like the ones with the, like it's a slot. Those are garbage, guys. Don't get those ones. Screws, those are the good ones. Right, because let's say that wire breaks off. You have a slot, then how are you going to reconnect it? That can happen. It's fairly common, actually. You're fucked up because of a little wire. Whereas, if the wire breaks off here, you can just put the wire around the little screw here, tighten it, and you're good to go. Right? So the little slot ones are fucking garbage. There's no way you can. It's really difficult to connect a wire to it if that little tab breaks off, which it breaks off. Sooner or later, that fucking thing does break off. It's not if, it's just when. Okay, so I actually bought 2 other relays. One of them I bought, it's basically a Chinese, but it's a starter solenoid relay. It's pretty big, it's got massive terminals. And once again, because it's a magnet, it's just a magnetic switch. It shouldn't matter, okay? Just some of them are bigger than the others, bigger terminals, whatever. If it's 4 terminals, which are 99% of them, it's still the same thing. You can still use it. know, they just use little. You can use a little. You can use a big one for a little, small application. If you use a small one of high amperage, you know, it might not be enough to carry the current. So basically, the thing is, you need thicker wire to be able to push for you know, higher amperage. So, for example, something that takes a lot of force, like the starter motor, you know, it's turning the engine. It needs a lot of force. Force in electrical terms is amperage. Okay, it needs a lot of amps. That requires thick wires. You put a thin wire, it's either going to heat up or it's going to heat up and then melt. Okay, so you know, you can use thick wire and thick terminals for smaller applications. For example, light bulb. You know, you can have massive terminals just to turn on a little light, 6-volt light bulb, 12-volt light bulb, but you can't do the opposite. You can't have, you know, a little thin wire for, you know, a big starter motor for a big engine. You can't do that, right? It's just gonna melt. So, you know, I can use a big relay for something for small application, but the solenoid, it's actually pretty strong. As you can see, I can pull it a little bit with my hand, but it really is strong, guys. So therefore it does require a lot of amperage, which means it does require thick wire. So that's why this relay, as you're going to see, is a lot bigger than this one. I believe the solenoid uses 40 amps for the first coil. Then it has two coils. One is for the initial torque, because just like the car, you know, in order to move something that's stopped, it requires more strength. So it needs 40. I think it's 40 amps. This requires more amperage, and therefore a bigger electromagnet to push it in, to pull it in, and then to hold it in. To hold it there, there's another winding, and it does use a lot less electricity. Because it's a lot easier to hold it there than it is to actually get it there. Okay. So I'm not sure this solenoid, this relay would work for that solenoid, but it was under $10. I think like $4 or $5. This one. I've actually even got a cheaper one from Amazon, probably from China. Well, everything's from China, except these good stuff here. Good American steel. Not that they make the same stuff now. They probably, Ford, all those guys, they just make the same fucking garbage as everybody else does now. Even the fucking Mustangs, Cadillacs, they're all fucking garbage now, guys. All fucking garbage. But anyways, let's not get into that. So yeah, that's that. So I think the Chinese solenoid, the Chinese starter relay that I got was for a starter. That's in the car. That's the thing. That's the component that uses the most amperage. Okay, that's the thing that requires more force than anything else. You know, you have relays. You might have, you know, light bulbs, switches. You know, have alternator, voltage regulator, but the starter motor turns the engine. So, you know, if it's a starter solenoid, starter relay that I bought, it should work for anything else. Okay, so and it's cheap. So, you know, I just bought it as a backup, and I just want to see if it works, because these ones are pretty expensive. I didn't know about that. I just looked at it and said, damn, I'm just gonna get the original. Now, it's just a switch, guys. A relay is just a switch. I know there's like other relays. You got like thousands of, hundreds of millions of terminals and this and that. But it's basically just lots of relays put together, okay? So this, you know, back then, it used to be as simple and nice, and just as simple and easy as possible. So any 4-terminal relay that's able to carry that current will work. Okay, so I'll just go ahead and open it up for you guys. I'm definitely not throwing the box away. I like the fucking like a child at Christmas time. This is a real movie. It's actually not that much bigger than the other one. So, you know, maybe the other one will work. I don't know. At least, you know, I have this one if I want to use it for something smaller. This one is certainly built a lot better. It's actually galvanized, nicer, you know, steel terminals, massive terminals. It's got a fuse, brass fuse, big copper contact points, thick, you know, insulation. This one's certainly better than the other one. I don't even have to look at the other one. It's all galvanized. It's really interesting. HR4201S. There you have it. Autolight, there's the Autolight symbol right there. I don't know if you can see it or not. That's how it looks. I know it looks pretty complicated, but you see, 1, 2, 3, 4. 4 terminals. Unfortunately, this one you can't really open it to see which one goes where. But usually the ones that are closer together are the ones that go for the electromagnet. And so probably these two are the outputs, but I mean, I've seen diagrams for these around, and you can, you know, there's other ways to test this and find out, but you know, that's for another video, and I just wanted to show you guys this now. Just thought I'd show it to you. I'll show you guys the other ones when they get here. Yeah, then I think there's just one more thing. All these internal parts, guys, and these external parts, they are interchangeable. The T96s, and I believe the T86 as well. All the R10 overdrives, they're all the same, regardless of which manual transmission they're behind. Okay, so like I said, they're compatible with various different manual transmissions, but the overdrive, you know, R10, you know, it's always the same splines, same parts, and everything else. Okay, so here in my case I have an R10 with the T96, but you know, other people have the R10 with the T85, or an R10 with the T86, or an R10 with the T90, you know, whatever. So all these parts, they will fit, but the output shaft on this particular overdrive, remember, this is the R10F. The other one is the R10B, I believe. But the shaft here, it's got a lot more teeth, like I showed you previously. And the guy that I bought it from, he didn't tell me anything about it, and I didn't ask him either. But along with this yoke here, this is called a yoke. This goes on to the end of the transmission, the output, and this end here connects to the drive shaft. Okay, so that's what it does. But along with it, with the this yoke, came this little piece of paper, cardboard, and it says 66 Pont 2-speed, 2SPD, which probably stands for 66 Pontiac 2-speed. So, you know, maybe this was from a 66 Pontiac 2-speed. I don't know, I'm just sharing this information there with you. You know, maybe spark your inner researcher there, and maybe it might be useful to you that's watching this video. So there it is. May or may not be. I have no fucking idea. Just sharing the information there with you. Right, but what I am certain is the part number on this yoke here. It's AJ4868-D. That's the part number for this yoke here. And it's got a manufacturer mark here, which is a big circle with an A inside. On the left side it's got a P, and then the middle's got a 5. No idea what that stands for either. There you go. There's the part number. Right. Alright, I think I'll just put the parts back together just before this video ends, and our tour of the Overdrive is pretty much at an end. Right, the next step will be to actually no, there's still enough. I mean, yeah, this part. I'm still gonna probably do a video of the end result of this nice and painted. Maybe I'll record myself painting it just so you can see, get a feel of what's going on, and show you the viscosity of the paint and all that, how to paint it. And then later, of course, I'll have to do a video of installing it in the car and how it drives, right? I think I've only seen one video of a guy showing showing himself, driving a car with Overdrive. At least in his video, he didn't show the actual Overdrive. He didn't show anything else, just video of him inside the car, which is, I mean, it's kind of silly, but I mean, it's okay. If it was the Overdrive, he was, overtaking lots of the modern cars, and probably people are thinking, like, what the fuck, man? This, 6-year-old car is, telling us to get out of the way. Yeah, that's how I fucking like it. Fucking goddamn garbage they have now. But, so yeah, I will put another video of, installing, putting it in the car. It's extremely easy. Just remove the other transmission. There's just 4 bolts that hold it in place. That's it. I'll force two support bolts, and that's it. It might get a little bit complicated if I want to go a little bit crazy. I want to put like not complicated. I'm certainly going to put a support. If I use the long transmission, I'm going to put a support. If I use a shorter one, it's probably good enough as it is. If I have the longer one, I'm going to put support on that other end. It's just too long to be supported by just one end alone. Even so, to put a support, you just get a couple of, like, a piece of rubber and a couple of bolts, or a U-bolt. That's done. Put it through the floor, and the carriage bolt on the top. And that's it. That should be fairly easy. The only thing that will be a little harder is the drive shaft, or the drive line, because it has to be shortened, and I'd like to get the drive shaft with the splines in the middle, the adjustable drive shaft. So that's going to be another video how the Overdrive. This is pretty much the end of the Overdrive itself. I've done the disassembly of 2 Overdrive transmissions. I've done the complete disassembly and reassembly of the T96 manual transmission, everything apart. I've cleaned it, I've studied it, and I've recorded what's out there for you to see. And finally, I have finished the series, this playlist of videos on complete detail how it works. What I will do, of course, is also show you guys how to drive it once we get to that. So I'll just end putting it back together. Said the oil that goes on here, there's lots of different ones, but it's basically the cheapest oil. You don't want any additives. That's what the manual says. No special additives, just plain old simple oil, GL1, GL2, or even engine oil. The manual actually says to put engine oil in the transmission. Isn't that just fucking beautiful? Man, modern cars, the fucking Germans, you can't put anything different. Nothing. You have to use their oil, which obviously is really expensive, right? I've seen a German car. This guy paid $60 for a quart of their fucking engine oil, fucking transmission oil. And you know what? The worst part of it is that probably if you actually don't use their oil, it'll probably actually ruin the fucking transmission. I don't know. Fuck, I don't even like talking about modern garbage. Okay, Paul is there. Just make sure you have it in. And I mean, once you get these things in, you really don't want to. I don't like moving them around while they're dry. Make sure. I'll zoom in. Might as well watch. I have to do it anyways. So. I don't like to watch, just don't watch it. Simple as that. See, make sure the pawl is in between that. It's in between these two little horns here. This little C. In goes the oil cup here. Just make sure it's clean. You'd be surprised at how much sand and dirt was inside at the bottom of the other transmission. This one was pretty clean, very clean. Just had some dirt and sand because the guy opened up the lid, and then all the dirt and shit that was on top fell inside. So put the snap ring. So be careful. Put one end in. Push it down. And you can put it with your hand like this. See, I just put it with my fingers. There you go. Make sure it's in there, nice and tight. Okay. See, pretty fast. I can do. Looks like you can do it in under a minute. What modern transmission? Guys, and this is actually true, not lying. What modern transmission today, if you can even call it transmission, can you reassemble, disassemble, and reassemble in under 5 minutes? Tell me. I'll be your slave forever if you can come up with an answer. I'm not kidding. I'll be your slave forever. These transmission guys, they're fucking beautiful. That's okay. Let's just use the hammer. Go a little faster. Again, I can hardly see where it goes. I think that's it. It's supposed to go really flush with the it's supposed to go flush with the one end in, Let's try. Oh. This one is being a bit of a bitch. Or it's just, there we go. See, just gotta go to the proper place. Use a chisel, tap it down. There we go. Make sure both sides are in. There we go. Oh fuck! Fucking forgot to put the shift rail. Oops. Damn it. Put it in afterwards. Maybe I'll have to remove that snap ring, that U-ring that I just put in. Fuck. So fucking tired. There you go. Out it comes. Fairly easy once again. This back so that I can get the shift rail in. Won't be able to put the housing today because it's still soaking in diesel. And I'm not going to record myself cleaning it. Maybe I'll just do a little short video just to make things complete later on. Go in it goes. See if they are aligned. Put your finger over the surface here. You shouldn't be able to tell the difference. Shouldn't be sticking out. Yes, and it should. The roller gear shouldn't be sticking in either. Looks like perhaps one end is just narrower than the other. I think. Yeah, it is. You're supposed to put it at one end. If it doesn't go at one end easily, apparently you're supposed to put it on the other end. They're in, nice. The shift rail won't come out once they're in, you see? Once again, just see that, you know, even if the shift rail is as far to the overdrive side as it can go, it's still in contact with the blocker ring there. See, so if I move this, you see, it won't go in, it won't go out anymore. There it is in, there it is out. It's still like 2 millimeters inside the meshed with the blocker gear there. This really confused me in the beginning. This is supposed to be like that. Oh, by the way, one thing I did not mention, the lockout switch. The lockout switch, it just shuts off. It's at the end, the shift rail, and when you put it in, when you put the car in reverse, or when you pull out the lockout switch, remember it causes the shift rail to move back. Doing so turns off the switch. And this switch interrupts the electricity to the solenoid. Now, remember, it's mechanically this here, doing this here, it mechanically stops the solenoid from going in. But that lockout switch, it's just basically an extra safety step there. Not only, you know, you have the mechanical part here stopping the solenoid from going in, but that one, the solenoid is not trying to go in the first place, and it's off. I mean, when you're in reverse, the speed is below the governor, so it's off anyway. But it's just, you know, like I said, an extra